Hey guys, welcome back. So in the last video, we saw how to insert a new node in a circular single linked list. Hope the concept was clear. Now in this video, let's see how does the algorithm of insertion looks like. So the name of the method is insert in a linked list. It takes head reference and the value that needs to be stored and at which location do we want to insert the new node. Now the first step is we create a blank node and we insert the desired value in the node. Then we will check if the list does not exist. Then we return an error message because in that case we cannot insert a new node. So in case if the list exists, then we come to the else if block. If location equals 0, that means if we want to insert at first position, then what we do is we update node.next is equal to head. What that means is we have to update the next reference of node with head. So what is in head right now? 001. So we insert same 001 here. So this will create a link between node and node 1. Now once the link is established, the next step is head is equal to node. So in head we have to update 666. So this will disconnect head and node 1 and create a link between head and the new node. Now the last step is tail.next is equal to head. So what is tail.next? Tail.next is this reference here. So right now this is pointing to node 1. So we have to update this value also. So from 001 we update it to 666. So once we update to 666, this will start pointing to the new node and the link between node 6 and node 1 gets destroyed. So this is how we insert a new node at first position. Now let's say if you want to insert the new node at the last position, then the control goes in this else if block. So let's see what we have to do in that case. So all that we have to do is node.next is equal to head. Means this is the node that we want to insert. The next reference of it needs to be updated with head. What is head? Head is 001. So we insert 001 here. So as soon as we insert it over here, a link gets generated and it links the new node with node 1. Now the next step is tail.next is equal to node. So what is tail.next right now? Tail.next is 001. So we need to update it to node, that is 777. Now the last step is tail is equal to node. So we have to update tail and it should be pointing to node, which is 777. So this link gets destroyed and it starts pointing to the last node, which is node 777. So with that we have successfully inserted a new node at the end of a list. Now let's say if we want to insert the node anywhere apart from the first and the last position, then the control will go to this else block and let's see how does this works. So this is our new node having value 5 located at address 888 which we want to insert, let's say in between 4 and 5. So what we have to do is we have to run a loop starting from 0 till location -1. So we'll start with the first node and keep going towards right till we reach location -1. That is, we stop here. Now all that we have to do is node.next is equal to temp node.next. So what is node.next? We are talking about this place over here. So this needs to be updated with the value stored in temp node.next. What is temp node.next? It is 444. So we add 444 here. So as soon as we add 444, a link gets generated between new node and node 5. Now the next step is temp node.next is equal to node. Now what is temp node.next? It is this place. So we need to update it with the node, that is 888. So we move 444 and instead of it we put 888. So this will automatically destroy this connection and create a new connection between node 4 and the new node. So node 4 now points to the new node and the new node now points to node 5. So this is how we successfully inserted a new node in the middle of a list. So if we compare this algorithm with the algorithm of single linked list, there is a small difference, and the only difference is these two statements over here, that is tel next and node next. Apart from that, everything remains as it is. Fine. So I hope that you have understood how to insert a node in a circular single linked list. Now let's see what is the time and space complexity of this algorithm. So creating a blank node and inserting a value in it is a constant time operation. Checking if the linked list is available or not is again a constant time operation. If we want to insert the node at the first position, then all we have to do is we have to update few reference variables. Again, all of them are constant time operations. In case we want to insert at the last location, still we have to update only few reference variables. So once again it will be a constant time operation. But if we want to insert the new node anywhere in middle of a linked list, then we have to loop through the entire linked list in the worst case. So that will take order of n time. Rest updating all reference variables will take order of 1 time. So if we add up all of this, the time complexity becomes order of n. Space complexity will be order of 1, and the reason is we are just using some temporary variables here and there, nothing more than that. So with this we end this video. In the next video we'll talk about how to traverse a circular single linked list. Thanks for your time. See you in the next video.